Hi everyone! Welcome to another exciting tutorial where we combine coding and fun. Today, we'll learn how to build a real-time multiplayer Connect 4 game using the powerful Phaser 3 framework and Playroom Kit. Creating multiplayer games can seem tricky, but Playroom Kit makes it incredibly simple with its built-in features for state management and synchronization. Whether you're new to multiplayer development or looking to streamline your process, this kit is a game changer. In this tutorial, we'll walk through how to transform a basic Connect 4 game into a real-time multiplayer experience step by step. Let's get started. So before we dive in, here are a few things to keep in mind. Some experience with TypeScript in Phaser 3 is helpful but not required for this video. This video focuses on integrating Playroom Kit, so if you need to brush up on Phaser 3, check out my detailed playlist in the description down below. Now that you know what we're building, let's set up the project. First, I'll show you where to download the starting template. From there, we'll walk through the starting codebase. We'll see how we can set up and run our project locally. Then, we'll take a look at how we can start to decouple our code, so then that way we can start adding multiplayer support to our game. From there, we'll take a look at how we can use Playroom Kit to add real-time features, and then finally we'll test our finished Connect 4 game. So to bootstrap our process of creating our multiplayer game, we're going to take an existing project template of the game Connect 4 that was built with Phaser 3, and this project template has been set up to allow 2 players to locally play the game of Connect 4, and we're going to extend this to add multiplayer support. So in the description of this video, there's going to be a link to this webpage here, as well as the direct download for the source code for the starting project template. So if you'd like to follow along with this video, please download that code now and open it in your IDE of choice. After you've downloaded the project source code, we need to install the dependencies we'll need for our project. To do this, you'll want to open up a new terminal window, and at the root of your project, you'll want to run npm install. This is going to go through our package.json file and install all of the dependencies that we need for our project. So after you've installed your project dependencies, we should be able to start our project. So if we do npm start, this is going to start the Vite dev server, and it's going to make our game available to us. Alright, so go ahead and click on that link. It should open up in your browser. And I'm just going to go to inspect, and I'm going to open up our developer tools. And so we'll see for our game, we're running Phaser 3.87. Alright, so from our title screen, if we go ahead and click, this should allow us to play our Connect 4 game. And so for our local multiplayer game, we can take turns between players 1 and 2, and we can play our game of Connect 4. Once a player is 1, we show a message that, hey, that player won. They can click, and we'll restart our game, and so they can play again. Now that we've set up and run our project locally, we're going to quickly review the existing code base. So in the root of our project, the .vs code folder here just has some settings for VS Code. If you're not using VS Code or you'd like to override these, you can go ahead and remove this folder now. The config folder, this has our settings for ESLint as well as for Vite for starting our local dev server. Our public folder has all of the assets that we use in our game. So we have a custom font as well as the images that we use for our Connect 4 game. Index.html is our main webpage for our game, and it links to our source code where we start our Phaser game. From there, we just have some additional configuration files for Vite and for tsconfig since we're using TypeScript for our game. So inside our source folder, our main.ts file, this is our main entry point for our Phaser 3 game. It is responsible for creating our Phaser 3 game configuration and then creating a new instance of our Phaser game. Our scenes folder has all of our Phaser 3 scenes. And so in our preload scene, this is where we load in all of the assets that we'll be using for our game. Our title scene is where we just show our splash screen where we have a demo playing in the background. And then when the player clicks, that actually starts our game. And this will transition into our game scene. Our demo scene, this is just on our splash screen here. The demo that's playing here, it's a separate Phaser scene that launches in parallel to our title scene. That scene gets shut down once we start our game scene. So now the game scene, this is our core Phaser 3 scene that has all of our actual gameplay logic tied to the game of Connect 4. So inside this class, this is where we create all of our Phaser 3 game objects, we handle our player input, and we pass all of this to an existing npm library that has all of the core logic needed for the game of Connect 4. So in this video, we won't be doing a deep dive into the core logic for the game of Connect 4. Instead, we're going to focus on the multiplayer aspect. If you are interested in learning more, I do have some existing videos on my channel that walk through creating this core logic for the game of Connect 4, and then how you can implement that logic in a Phaser 3 game. There'll be some links in the video description, as well as some links on your screen now to these videos. And so just for reference, I have this playlist here on how we build this Connect 4 library, and then this video here where we create a Phaser 3 game using that library. So how our game is currently set up is in our game scene class, we're creating an instance of our Connect 4 class from our usable library. We then create our Phaser 3 game objects, and then we listen for input. When the player clicks on one of our zone game objects, we grab the ID of that zone that represents our column, then we pass it to our library to make a move. After we do that, we're creating a new phaser game object to represent that game piece, and then we're animating it onto our board to have it drop down into the position it needs to be in based on the results from our library. And then so after we add our game piece, we check to see if our game is over. If the game is not over, we allow the player to make another move until finally someone wins the game or ends in a draw. Once that happens, then we go ahead and display our message to the player that says, hey, this player won, and they can click to play our game again. And so that's just a very high level explanation of what we're doing in our code. And so in our current implementation, our Connect 4 core logic is very coupled with our Phaser 3 game logic. And for our multiplayer game, we're going to want to decouple these two things. And so the reason we want to decouple our Connect 4 logic from our Phaser 3 game code is currently for our local game, both players are playing on the same game instance. Once we talk about multiplayer, typically we'll have more than one game instance, and we need something to notify both of these instances of our game state. No matter what we choose for our multiplayer implementation, ideally our game state should be coming from one spot and then being passed down to each of our game instances, and then that way we can update our game instance to render out the representation of that state. And so to see a visual representation of this, currently this box here represents our existing Connect 4 game. This has all of our Phaser 3 game code and our Connect 4 game code as well. Our Connect 4 game code is already separated out from our Phaser 3 logic as a reusable library, but everything's happening in this one space. We have our game rendering, we have our player input, we have the Connect 4 game logic. And so what we want to do is we want to split this out so we have a complete separation. We'll have our Phaser 3 game code, which will be responsible for just rendering out our game objects and handling our player input when they interact with our canvas element. On the other side, we're going to have our Connect 4 game logic, which we already have isolated, but we want to split that out of our game scene. To do that, we're going to introduce this concept of a service. And so the service component here, this is going to serve as a bridge between our Phaser 3 game code and our Connect 4 game state. It's going to be responsible for abstracting away any of the implementation that's needed for the type of Connect 4 game we're creating. And what I mean by this is we can create multiple instances of our service component, and each one would be responsible for having the logic that's needed to support a different game type. As an example, we could create local component services where our player could play against a CPU or play against another player locally, or we could create multiplayer component services where each of these instances could have logic for connecting our players together. And so this could be over WebSockets, WebRTC, Socket.io, Khaleesi's, Playroomkit, REST, or any other type of service that we want to integrate with. When we create our component, it would have all of that logic that we need. And by putting this all in our service layer here, it allows us to separate all this logic out, and we can easily switch this component around in our game and toggle our different gameplay types. So now for our service component here, we're going to create a base class that all of our service implementations will extend. And on this base class, this is going to have all of the common properties that we'll need for our Connect 4 game, and it will have all the logic we need for connecting our Connect 4 logic with our Phaser 3 game. So in our service class, the first thing we'll do is we're going to add a Phaser event emitter, which will allow us to send events between our service and our Phaser 3 game. We'll then create a local instance of our Connect 4 game library, and then that way locally, each player on their game will have an instance of our Connect 4 game, and it's going to mirror our state that's coming from our service. We'll then have properties or getters for getting information like which player's turn it is, if the game's over, if it's currently my turn, the game winner text, and the player's turn text. And so by placing those properties on our base service class, we'll be able to override those and create custom versions of these for each of our implementations. Then we'll add a couple of public methods to our class, connect and make move. Make move is basically we'll take our column the player clicked on, and we're going to update our Connect 4 game state. And then finally for our connect method, this will be used for doing any setup logic that's needed for our service. As an example, in our local instances, we won't need to do anything, but if we connect to like a third-party service like Playroomkit, we need to provide our configuration for connecting to the Playroom API service. And so that's going to take care of our base service class, and then each of our service instances, since we're extending that class, they'll be able to add in their own properties and methods for that implementation. So to quickly recap what we just went over, Our existing code base for our Phaser 3 game has our logic for Phaser 3 and Connect 4 very coupled together. And if we want to introduce a third-party service to add in our multiplayer support, it's going to be very hard to do currently with how our code is set up. We want to split out these two things and introduce a new component to connect these two things together. Our service component is going to be responsible for taking our input from our Phaser 3 game, then passing it off to whatever service we implement. This could be a local service, or it could be an integration with a third-party service like Playroom Kit or Khaleesi's. And so our service component is going to have its own Connect 4 game state. It's going to get updated from that service. We'll then pass that information back to our Phaser 3 game state, so then we can render out our actual game state of Connect 4. And so by taking this approach, we'll be able to switch out our various service implementations, and we won't have to modify our actual game logic for Phaser 3. And so we'll see an example of this when we switch from our local multiplayer to our Playroom Kit instance. And so now to get started with our changes, let's jump over to our code and we'll create our new service class. So now we have a plan in place, we can start adding in our logic for our service class. And our service class, we want this to be a blueprint or a base class that we want all of our other implementations to extend, and then that way our base class is going to have all of the common functionality that we need for each of our implementations. We don't actually want to create an instance of the service class directly, we'll want to create an instance of one of our implementations. So for that, we're going to make our service class an abstract class, and then that way we can extend it with our other implementations. To do this, let's go into our source folder, let's do services. Let's add in a new file. We'll do service and we'll do .ts. So now we'll do export abstract class and we're going to call this service. Let's add in our constructor. So on our class, we're going to want to add in our various properties, getters, and methods to match our definition of our service here. All right, to get started, let's add in our properties for our class. So for our properties, we want these to be available on our child instances of our service class, but we don't want them to be available to the public. And so we're going to make these protected by default. And now let's do events. And this will be our Phaser events event emitter. Next, we need our Connect 4 game instance. So let's do protected. We're going to do Connect 4. We'll set that equal to our Connect 4 instance from our library. Next, we'll want to add a property to keep track of our overall game state. And so we're going to have three main states, waiting, playing, and finished. Waiting will be the state where we're waiting for everyone to connect to our game. Playing is when we're actually playing our Connect 4 game. And then finished is once the game is over. We'll be using this game state property internally in our service to allow us to do things like block player input when we're in the wrong state. We'll be able to check to see if we're already playing a game if a new player tries to connect, and other things like that. So for this, let's do protected. And we're going to call this game state. Now for this, we're going to want to add a new type. So we're just going to call this game state. All right, so now we need to define the actual game state. For this, if we go into our source folder, if we go into common, let's go into our index.ts file. This has all of the common code that's used throughout our game. And so we'll add a new object here to represent our game state. All right, so let's add a new variable to represent our various game states. So I'm going to copy our game assets here. I'm going to go ahead and paste it down here. Let's change this to game state. And then for our keys, we'll do waiting for players. We'll do playing. And then let's do finished. We'll get rid of our last property here. Now for our values, we're going to update these to match our keys. All right, so all we're doing here is we're just defining an object that has all of the properties that we want to use for our possible values for game state. You can also replace this with an enum if you prefer to use enums in your TypeScript code. So now that we have our game state object, we're going to add a type to represent this. And to do that, we're just going to do export. We're going to do type. Let's do game state. We're going to set equal to key of, type of, game state. Now what this will do is this is going to make this type available to us, and then we'll have our various values from our object. So now if we jump back over to our service, we should be able to do game state. We'll be able to grab that from our common file, and now it's updated. All right, so for our class, we're just going to add in two more properties. These are going to be for our player 1 and player 2. The text we display when they win. So let's do protected. We'll do player 1 wins text. For our type, we'll do a string. Now let's copy this and we'll do player 2 wins text. So now we have our properties in our constructor. Let's go ahead and set up these values. So for our events, we're going to set that equal to a new Phaser events event emitter. So now that we're referencing Phaser, let's add in that import. We're going to do import asterisk as Phaser from our Phaser library. So after our event emitter, let's create an instance of our connect4 game. So we'll do this, we'll do connect4 equal to new connect4. For our game state, we'll start off in our waiting state. And now for our text, we'll do this. Let's start with our player 1. Player 1 wins text. We're going to set equal to player 1 wins. Copy this. And let's go ahead and paste that here. And so we'll do player 2, and we'll do player 2 wins. All right, so what we're doing here with our player 1 wins text and our player 2 wins text is currently in our game scene, we have this text string hard-coded for our win text based on our state in our connect4. We want this to be dynamic based on our service implementation, and then that way, like when we're playing locally, player 1 and player 2 makes sense, versus if we're playing online, we might want to say you win or your opponent wins. And so we'll be able to override these values since they're just protected on the various implementations of our class. So now that we've defined our properties, let's add the getters that we'll need for our class. First, we're going to go ahead and add a getter for getting our events. And so we'll need to expose our phaser event emitter. So that way in our phaser game, we can register listeners for the various events we're going to emit. So we'll do phaser events event emitter. We're going to return this and we'll do events. So I'm just going to copy this block of code here. Next, we'll want a getter for if the game is over. So we'll change this to is game over. This will be a Boolean. Now for this, we want to reference our connect4 game instance, and we'll do is game over. Next, we're going to add a getter for getting the current player. So we'll do get, and we'll do current player. For our type, this will be our connect4 data, and we'll do player. And we'll do this, we'll do our connect4, and we'll do player's turn. Next, we'll add a getter for our game state. Go ahead and paste in our code. Let's change this to game state. For our type, let's return game state. And we'll do this, and we'll do game state. Next, we'll want to getter for our game winner text. So we'll do get game winner text. This will return a string. And so for this, we're going to want this to be dynamic based on who won the game or if the game ended in a draw. If we jump over to our game scene, we'll see we have existing logic for this, where our default text is draw. And then if we do have a winner, we update our text to reflect that. So in our getter here, let's first check to see if we actually have a winner. So we're going to do if this connect4.gameWinner is equal to undefined, then we can return draw. And so if it's not undefined, that means one of our players won the game. And so we'll do if this connect4.gameWinner is equal to connect4 data, and we'll do player 1. If player 1 was the winner, we're going to return this player 1 wins text. Then finally, we're going to fall back to player 2 wins text if player 1 did not win. Finally, we'll add in one more getter, and it's going to be for checking if it's currently my turn. For this, we'll want to make this an abstract getter. We'll do abstract get is my turn, and this will return a Boolean value. The reason we're making this abstract is this is going to be different depending on our implementation. As an example, if we're doing local multiplayer, is my turn should always return true because the game's being played locally and we don't need to lock our state for that player since they're taking turns. Versus if we're doing multiplayer where each player has their own instance of the game, we'll want to lock our state if it's currently not their turn. And so this is going to require for each of our implementations that we implement this getter with the relevant logic. Now that we add in all our getters, now we just need to add in our methods we'll need for our class. For both these methods, we'll make them abstract, so we need to implement them in each of our implementations. Let's do public, we're going to do abstract, and we'll do connect. For this, we're going to return a promise, and we're going to have that promise resolve into a Boolean. Now we'll do public abstract, and we'll do make move. We'll receive one argument. It's going to be the column of where we placed our game piece. So our column is going to be a number, and we'll have a return type of void on that method. So now that we've created our abstract service class that will act as the backbone for our different game modes, we now need to update our phaser game to rely on our service instead of our connect4 library directly. Since our service is an abstract class, we now need to create an implementation of it. To start with, we're going to add a local service instance that will allow us to test our game quickly before we start adding in our multiplayer for Playroom Kit. By starting with our local service, we'll be able to see how we can use our event emitter to emit changes from our service to our Phaser 3 game, and then have our game state react to those changes. So now to create our local service implementation, let's go into our services folder, we'll make a new file, we're going to call this localservice.ts, export class, we'll do local service, and we'll do extends, and we'll do our service class. So now we need to implement our abstract getter and our two abstract methods. So I'm going to come to our service class. Let's copy our definitions for those here. We'll paste that into our local service. Let's get rid of our abstract keyword. So for is my turn, we're just going to have this default to return true. Since both of our players are playing locally, it should always be one of their turns. So now for connect, we need to return a promise. So we're going to do return new promise, we'll add in our resolve keyword. And for now, we're just going to resolve and we'll return our Boolean value of true since we don't need to connect to a third-party service. So now for our make move method, the main thing we need to do is we need to update our connect for state with the move that was just made. For that, we're just going to do this. We'll do connect for, we'll do make move, and then we'll pass in our column that was provided as an argument. So now we have our basic definition for our local service. We now want to start updating our game scene to use our service instead of relying on our connect for instance directly from our library. So let's jump over to our game scene. Let's replace our connect for property with service. And for our type, we're just going to do service. We won't specify a specific instance. Now we can get rid of our init method since we'll create an instance of our service in our create method. So right after we disable our input, let's create our game service. So let's do this service is going to be equal to a new local service instance. So then after we create our service instance, now we need to attempt to connect to that. For that, currently our phaser scene is set up, so we have a fade in effect. And after a fade in effect completes, now we want to try to attempt to connect to our service. So right now there's just a comment in there for to be implemented. Let's remove that. And now this is where we'll connect to our service. So do const, we'll do connected is going to be equal to await this, our service, and we want to call connect. All right, so then after we connect, we just want to make sure we actually connected. So we're just going to do if we didn't connect, then we're just going to log a message for the time being. So we'll do console.log and we'll say failed to connect to service and we'll do return. If we did connect, we'll just do console.log and we'll say connected to service. So now what we'd want to do is if we fail to connect, this is where we want to do something more graceful. So like if it was an online game, we might fall back to allowing the player to play locally offline, or they could play with bots, or we might attempt to try to reestablish connection to that third-party service. And so for the time being, we're just going to go ahead and log a message, and this is something you'd want to address in your actual game. So now that we've connected to our service, now we need to update the rest of our code to reference our service instead of our connect for instance. So if we come down to our create input columns method, we have a few references here. So we're going to replace this.connect for is game over with our service, and we'll reference our is game over getter. Next, for our pointer down, this is where we're calling make move on our connect for library. We're going to replace that with a call to our service. So we're going to do this, we'll do our service, we'll do make move. Now let's copy what we're passing for our values here. We'll paste it here. Then we're just going to comment out these lines of code and we're going to come back to it. Because currently what happens is after we make our move, then we're calling add game piece, which creates our new phaser game object. We won't want to do this directly, but we'll come back to that. So now in our check for game over method, let's replace this connect for is game over with this service is game over. All right, so then next, instead of doing this connect for is player's turn is equal to player 1, we want to change this to be this.service, and we'll say is my turn. So for our local service, this will always return true. And so the idea here is as soon as we add in our multiplayer, is my turn should only return true if my instance of the game, if it's actually my turn to provide input. All right, so next, if our game is actually over, then we're updating our win text variable, and then we're adding that to our message we display on our screen. So instead of doing win text, we're just going to reference our service, and we'll use our game winner text getter. So then we can remove this logic here, so we no longer need it. All right, so if we want to test our changes so far, let's jump over to our preload scene. We're going to update our default starting scene. So we'll go from title to go right into our game scene. And this will just save us a click and having to wait for our game to actually start. So now if we come over to our game scene, we'll see right away in our console, it'll say, hey, we connected to our service. And now if we click, nothing happens in our game. And that makes sense because back in our game scene, all we're doing is we're calling make move on our connect for once we handle our player input, but we're not actually adding a game piece. So as an example, if I keep clicking on the same column, we'll see eventually we get to an error, and what's happening is we're filling up our column in our local state, but our game doesn't actually represent that. So to fix this, after we call our make move method in our local service, and we update our connect for game state, Now we want to notify our game scene that, hey, our state has changed, so we need to update our representation of our game. So now to notify our game scene when our state is actually updated after we make a move, we're going to make use of our event emitter that we added to our service class. For our event emitter, we'll have our service emit an event after the move is made, and we'll have our game scene listen for that event, and then this is where we'll trigger our previous logic where we're adding in our game piece. To do this, let's go ahead and define our event that we'll want to use. So if we come over to our common index.ts file, we'll make a new object to represent our events. So I'm going to copy this here, we'll go ahead and paste it. Instead of game state, we're going to call this custom game events. Now for a game events, we'll do game piece added to the same value. Let's add in our type for this. So I'm going to copy this, come down here, and now we're going to call this custom game events. All right, so one other thing we'll want to add is when we send this event to our game scene, we'll need to pass along any data that our game scene will need to render out our game object. Currently in our game scene, when we call our add game piece method, we need to know the position of where our game piece will be positioned at, and we need to know which player added that game piece. And we use that data to animate our game piece down to its position and to show the correct frame, the correct texture for the game piece. Since we're passing this data along, we'll define a type for it. This will export type, and we'll do game piece added event data. So we'll set this equal to an object, and we'll do a coordinate. And now for our type, we're going to do our connect for data, and we'll do our coordinate, and then we'll do our player. And so now we'll do our connect for data, and we'll do our player. So back in our local service, we want to emit this event. So after we make our move, we're going to do this. We'll reference our events. We'll do emit, and we'll do our custom game events. And now we need to pass in our data that we want to pass. So let's make a new object. We'll do const data. Let's set equal to our type. So we'll do game piece added. And so for our coordinate, this coordinate's going to come from when we do our make move here. So let's store this in a variable. And then we'll pass that here. And now finally for player, we'll need to pass in which player actually made this move. So after we call the make move method on our library, our current player is going to get updated. So we'll need to grab a reference to our player before we call this method. So let's store our reference. We'll do const, we'll do current player. It's going to be equal to our connect for, and we'll do player's churn. And now we can pass that here. All right, so now when we emit our event, we actually want to pass in our game piece added, and now let's save. So if we come over to our game scene, now we need to register an event listener for this event. So let's come down to the bottom of our class. We'll make a new private method, and we'll do register event listeners. And for this method, we won't return anything, so we'll set our return type to be void. So now to register our event listener, we're going to do this. We'll reference our service, and now we're going to do events, and we'll do on, do our custom game events, our game piece added. Now we'll have our callback, so we'll have our data. We'll do our game piece, added event data. And so now we can call our add game piece method. So we'll do this, we'll do add game piece, we'll do our data, our coordinate, followed by our row, our data, our coordinate, followed by our column, our data, and then our player. So now we need to invoke our new method. Let's come to our create method. All right, so right after enable input, let's call our new method. So we'll do this, register event listeners, and then let's go ahead and save. All right, so with our new changes, let's go ahead and test our code. Come over to our game. Let's go ahead and try clicking. We'll see now we are able to add in our various game pieces and we're able to play our game. However, our text is not updating for our player name. So we come back into our game scene. All right, so go ahead and fix our text. What we need to do is in our enable input method, we need to update our game text that's being returned. What's happening is after we place a game piece and we're checking to see if our game is over, because isMyTurn is always returning true, that results in only enable input being called for our game. So we're going to want to change this to be, instead of player 1's turn, we're going to reference our service and grab which player's turn it actually is. So we're going to change this to our string. We'll do this. We're going to do our service, and we're going to reference our current player. So now if we save, we come back to our game. If we click, we'll see now our text should get updated between player 1 and player 2. All right, so now that we have our logic working for when we emit our event for our game piece being added, we need to make a few more changes to our game scene. Currently, when our game scene first starts up, our players are able to start playing the game right away. And we actually want to wait before we start allowing the player to play our game until we're connected to our service and all players are actually in our game. To do this change, we need to disable our input until we're notified by our service that our game state has been updated. To make this change, let's come up to our create method, and let's get rid of our enable input method here. Now when our scene refreshes, we'll see that we have our game piece here, but our player's not actually able to click and do anything in our game. So let's update our text to show that we're actually waiting for an event. So we come down to our method for our create game text. We're going to see we have an empty string right now, and let's just default to waiting. Now when our scene refreshes, we'll see that we have our game piece and we'll show the waiting message to the player. Let's hide our game piece as well. Alright, so to make this change, let's come up to our create input columns method. Inside this method, this is where we create our game object that represents that game piece. So we'll have this.game piece. We want to call set visible, so it's not visible by default. We're going to set it equal to false. So now if we save, when our scene refreshes, we see our waiting message and we don't see our game piece. Alright, so now we need to update our local service to actually emit an event once we're ready to start playing our game. For this, in our connect method, this is what we'll emit that we're ready to start our new game. And so we'll do this, we're going to do events, we'll do emit, and now we need to do our custom game events, and we need to define a new event for this. So let's do new game started. And when we pass this event, we don't need to pass any data. So let's go over to our index.ts file. Let's add in our new event type. Let's save. We'll come back to our local service. We'll save. And now in our game scene, we'll come down to our register event listeners. Let's copy this logic here. Go ahead and paste it. And now we want to listen for our new game started event. For our callback, we don't need any arguments. So now in our callback, we'll want to reset our text up here for which player's turn it is. And so we'll do this. We'll do our current player's turn text. We'll do set text. And we'll do an empty string. Alright, so now after we reset our text, now we want to go ahead and enable our input. Before we do that, we'll want to make sure it's actually our turn. And if it's the opponent's turn, then we don't want to do anything. We want to wait for our opponent to make a move. So currently, because we're using our local service, our events happen quite quickly, and so we can test everything. We're just going to introduce a slight delay. And so we're going to do this. We'll do our time. Let's do delay call. We'll do 1,000 milliseconds. Now in our callback, we're going to check our service. We'll do if our service, if it's our turn. Now we want to enable input, and we'll return. If it's not our turn, we'll just call disable input, and then that way we can display a message saying it's our opponent's turn. So let's come into our disable input method. What we'll want to do is currently we have our enable set to true and visible set to true, and this is because we had both players playing locally. So now let's go ahead and set these to be false since we're setting this up for a multiplayer. So now if we save, our game should refresh. Let's refresh our scene, and we'll see waiting. After a second goes by, now it shows it's player 1's turn, and now we can make our move. It gets updated to be player's 2 turn, and now we should be able to play a full game of Connect 4, just like we did before. Alright, so one quick change we're going to make is we're going to move our logic for when our new game is started into its own method. This will help keep our code clean since we'll have our event listener code be very small and it's just to invoke other methods in our class. So that in a new method, we're going to do handle game started. For our method, we won't return anything, so we'll do a return type of void. Now let's just copy all of this logic here. Let's go ahead and paste inside our method, and we'll replace this with this, and we'll do handle game started. So we save real quick, we should be able to test our change, and we should still be able to play our full game. So now we've finished refactoring our code, and we've created our local service to test our refactor. It's now time for us to create an implementation of our multiplayer service. So instead of building our multiplayer game from scratch, we'll be taking a look at the Playroomkit library and how we can use this powerful library to quickly add multiplayer support to our game. So if you're not familiar with Playroomkit, Playroomkit is a powerful yet beginner-friendly library specifically designed for building real-time multiplayer games for the web. And with this library, we can easily integrate this with our Phaser 3 game. It simplifies the complex challenges of creating multiplayer games and allows developers to focus on designing fun and engaging gameplay rather than worrying about intricate details of networking and synchronization. And so what's really cool about the library is you can quickly prototype your multiplayer game without adding any back-end code. And so just to see an example, we can easily take this Phaser 3 game here, where we have 2 game instances and we have a player moving their character around, and we can see how the state is synchronized between both game instances. And so we can easily create this type of game by integrating the Playroomkit SDK into our games. And so some of the benefits of using Playroomkit is you no longer have to manage and oversee WebSocket, TCP, or WebRTC protocols along with your server backend. Instead, you just focus on your game and the client side, and then Playroom's going to manage the rest for you. And so the service allows us to have 0 backend setup, and so we can quickly prototype our games, and it offers low latency in automatically handling the switching between WebRTC and WebSockets to make sure our players have the best experience. On top of this, the library is designed with simplicity in mind, so even developers new to multiplayer concepts can quickly get started with the SDK. The API is very straightforward, and so with just 6 lines of code, we can easily add multiplayer support to our game. Alright, so before we dive into our code, we're going to quickly go over the Playroomkit SDK and the various API methods we're going to need to invoke in order to add multiplayer support to our game. And so as a first step, we need to add Playroomkit to our project. To do this, Playroomkit is available on the CDN and as an NPM package. For this step, we don't need to do anything. In the initial project template that was provided, our dependency for Playroomkit is already present. So when we installed our project dependencies, it's already added Playroomkit to our project. So besides the Playroomkit SDK, we also need to add in the React and React DOM libraries. And the reason we need these is these are peer dependencies for Playroomkit, and how Playroomkit uses these two libraries is when a player first joins our game, they're presented with this lobby here. And so this is available out of the box, and what this lobby does is Playroomkit's going to automatically generate a unique room ID to allow players to join the same game instance. And from this lobby, players will be able to choose a random avatar, modify the colors, provide a name for the game. And then once the host player clicks launch, so the main player, this will actually start our main game. And so this lobby, this GUI is made with React and React DOM, and out of the box, this is what's shown to the player. There is support for your own custom lobby if you want it, but we'll be using the default lobby for our game. And so to use that, we need React and React DOM. Those have also already been added to our project package.json file, so no action is needed there. So after we've added in the library to our project, now we need to tell Playroomkit to actually start. And to do this, we call await insert coin. What this method is going to do is this is going to show that lobby here unless we bypass it with a custom lobby or choose to skip it. And now this is where we can wait for players to join our game before we actually start it. And so this is going to return a promise, and it's not going to resolve until our game is actually started and either the main player clicks launch or the player's automatically added into our room and then they see our phaser game. So once that promise resolves, now we can actually run the logic for our phaser game and start handling our player input. Alright, so after we call insert coin, the next thing we need to do is we need to add logic to handle when players join and they quit our game. We can do this by using the onPlayerJoin method to provide a callback to let us be notified when a new player joins our room. So how Playroomkit works is when we first visit our URL for our game and we call insert coin, it's going to generate a unique room ID if one does not already exist. And then if another player visits that URL, they'll be put into the same game instance as long as that room ID is the same. When this happens, this callback is going to be invoked, and so now we'll be notified in our game code that there's a new player, and now we could do things like create game objects to represent that player. And so that's going to handle when players join, so now when players quit, we can register a callback for when a particular player leaves our game. And so now, if a player gets kicked or if they leave our web page, now we'll be able to handle that in our game, and we'll be able to clean up those game objects that are tied to that player. Alright, then finally, now we just need to synchronize our game state between all of our players. To do this, we'll rely on Playroomkit and its ability to synchronize state across all of our players, and how this works is, since there's no backend, Playroom's automatically going to choose one player to be our host player for our game. The host is going to act as the authority of our game state, and so all other players should not modify the state directly. Instead, the change should be submitted to the host player, and then the host will update the main game state and share it with all players. And so this is important to know because typically with some multiplayer games, you may want your game state managed on an authoritative server, and then that way it helps prevent things like cheating. With Playroomkit, there are new features coming to support this, but at this time, since there is no backend state, we have to manage this on the client side. And so this is perfect for games where we want to prototype or for simple casual games like we're building here. And so with Playroomkit, we have two different types of state. We have our global state, which is shared between all of our players. This is great for things like keeping track of how much time is left in a level, what the current level is. And then there's the individual player state. This is specific to each player. And so this is perfect for like an individual player's score or maybe their position in the game. And so depending on which state we're modifying, we need to either call set state from the SDK directly or on the actual player's state that we're modifying. Besides modifying our state, the other thing we're going to rely on is the RPCs. So an RPC is a remote procedure call, And this is a way for us to have one player call a function on another player's client. How this works is we can register a callback that we want to be invoked when we receive a message from another player. And so this is perfect for things like when we shoot a bullet or we have a chat message, we take damage. When one of these players do these actions, we can now notify the other player that's affected. And then that way we can react to that in our game. And so how we'll use RPCs in our Connect 4 game is we're going to have one for when a player makes a move. And so if we're not the host player, we're going to notify the host to say, hey, I just made a move in column 2. And now the host can update our game state and then broadcast that to all players through another RPC. And so for the RPCs, there's a few different ways we can trigger them. We can choose who the target of that broadcast is. So when it's host, only the host client will be notified. If it's all, then everyone will be notified. Finally, if it's others, then whoever makes this call, everyone else will be notified except for the person that made that call. All right, so at a high level, that's all we should need to do in order to add multiplayer support to our Phaser 3 game. So we won't be doing a deep dive into the API documentation, but if you are interested in learning more, there will be a link in the description of this video to the documentation. So now we review the SDK and the methods that we need to implement at a high level. So let's jump back over to our code and we'll start implementing our multiplayer service with Playroom Kit. All right, so back in our code, let's start off by creating a new file for our Playroom service. So under our services folder, let's do new file. We're going to call this Playroom service. Let's create our class. We'll do export class. We'll do Playroom service, and we're going to extend our service class. I'm going to jump back over to our local service. I'm going to copy our logic here for our getter and our 2 public methods. We'll go ahead and paste that in. All right, so in our connect method, let's remove our logic for emitting an event and make move. We're just going to go ahead and remove all that logic as well. And we're just going to have it to do. All right, so first, let's import the Playroomkit library. So we're going to do import asterisk as Playroom. We'll do from, and we'll do from our Playroomkit npm package. All right, so now that we have the library, the first thing we need to do is we need to start Playroomkit. To do this, we need to call that insert coin method. So in our connect method, let's change this to be public, and we'll do async, and we'll have connect. Let's get rid of our promise here. Now we're going to do await. Let's do Playroom, and we'll do insert coin. All right, so now that we're waiting for a promise, let's wrap this in a try catch so we can handle any errors. And so we'll have try catch. We'll have our error, and if we get an error, we'll do console.error. And then the error that we received, and we'll return false if we're not able to connect. Otherwise, we'll return true. All right, so for our insert coin method, one of the things we can do is we can provide some configuration options that we like to be applied to our game. One of these that we can set is our max players per room, and what this setting does is allow us to limit how many people are actually allowed into our room at one time. So by default, when players join our room in Playroomkit, if we don't have a max capacity, players will be able to keep joining. And so for Connect 4 game, we can only really support 2 people. And so we're going to limit it to 2 players. And what will happen is Playroomkit will automatically handle when more people try to join. It's going to show a message and say, hey, the room's already full. And we don't have to handle that ourselves. And so we'll see an example of that once we connect all of our code together. All right, so after we call insert coin, now we need to add in our event listeners for when a new player joins our game. To do that, we'll add a new private method to our class, and we're just going to call this register event listeners. And so inside this method, we'll do Playroom, and now we'll do onPlayerJoin. And so when a player joins, we're going to receive that player's state. And so we're just going to call this player for our argument. All right, so when a player joins our game, we'll need to keep track of the player state associated with that player. To do that, we can build a map of a player ID to our player state. So anytime a new player joins our room, Playroomkit's going to generate a unique ID for that player. So to keep track of this, we'll need to add some properties to our class. The first one we'll do will be our player IDs. And so we'll make a private property. And for this, we're just going to do a set of strings. Next, we need to do our player states. So we have another private property. And now this is just going to be an object where our key is going to be our player ID, so it'll be a string, and this is going to map to our player state. So we'll have Playroom, and we'll have player state. So let's add in our constructor so we can add in our default values. And so we'll have constructor, let's do super, so we'll call our parent class, and now we'll do this, we'll do our player IDs is going to be equal to a new set of strings. We'll have an empty set, now we'll do our player states, and we'll set that equal to an empty object. All right, so now down on our callback for when a player joins, First, let's log a message. We're going to do console.log, and we're just going to say player joined, and we're going to log out their player ID. All right, so let's go ahead and update our state in our class. And so we'll do this. We'll do our player IDs. Let's add our new player ID that just joined. And let's update our states. We'll do our player states. We'll reference our player ID. We'll set it equal to our player. And now we're just going to log out one more message. We're going to log out all of the player IDs that currently exist in our game. So we'll do console.log, and we'll do existing players for this room. And we'll do an array from our player ID set. All right, so one other thing we'll do is we're just going to add a safeguard in case we get duplicate events. For this, we'll add an if statement. We'll do our player states. And so if we have a player state for provided player ID, then we'll just return early and not do anything else. So after we update our state, now we want to register our callback for when a player quits our game. So for that, we need to reference our player state. And now we can call the onQuit method to register our callback. And so now in our callback, we'll receive information on which player just left our game. I'm just going to add a new argument. We'll do player that left. And so this will be the player state of the player that left. After this, we'll do another console log, and we'll say player left, and we'll log out their player ID, and we'll player that left ID. So now when this happens, we'll want to clean up our state. And so we'll do delete this, our player states, and we'll do our player that left ID. And now we want to remove that from our set of player IDs. We'll do list.player IDs, we'll do delete, and we'll do player that left ID. All right, so finally, let's call our new method from our connect method. So before we call insert coin, let's register our event listeners. All right, so if we want to test our changes, let's come back into our game scene. And now we want to create an instance of our Playroom service. So let's comment out our code tied to our local service. And now we'll do this.service is going to be equal to a new Playroom service. All right, so if we go and save our changes, if we come back to our browser, we should see now after our game starts, we should now connect to Playroomkit. And now we see the lobby for the room that we just joined. And over on our console, we'll see our callbacks are being invoked. So we see a player joined and we have our unique ID. We'll see we're the only player in the room right now. All right, so if we copy our URL here with our unique room ID, if we open up another tab, if we go ahead and go to that same URL, we'll see a new player is now created. And now we have 2 players in our current room. Back in our first instance, we'll see that our player joined callback was invoked with a new player ID. And now we have our 2 players. If we go ahead and let's try to visit a different room ID, what we should see now is for our second player, now we're in our room by ourselves and we're the host player. Back in our first game instance, we'll see a player left and we have the ID of that second player that left. All right, so just to see if another player joins our game, let's copy our URL. We'll open up a new tab. When we do that, we'll see we're in our existing room. We now have 2 people in our room. Back in our first game instance, we now have a new player joined with this new ID. And we'll see now we have 2 players in our room again. All right, so finally, we're just going to test what happens when we reach our max player limit. Let's copy our URL one more time. If we go to our new tab, if we go ahead and paste that in, we'll see now Playroomkit's going to show a message to the player that says, hey, our room is full and our game's in progress, so we're not able to join this room. So now when we close, we'll be taken back to our game instance where our player will be able to reconnect to a different game instance. All right, so now we have our basic functionality in place for allowing our players to connect together and for handling when players leave our room. Now we need to define our state that we want to be managed by Playroomkit. So for our state, the main thing we want to have managed is the overall state of our game. So for our game, there's a few different ways that players can join and leave our game, which results in the different scenarios we need to cover. The first scenario we saw was both players join the same room, and then our host player clicks launch, and now both are taken into our Connect 4 game, and they should be able to play the game. Our next scenario is we have a player create a new room, and they click the launch button right away. What this will do is it's going to drop them right into our Connect 4 game, but we only have 1 player. And so really, we need to wait until that second player joins our room before we start our Connect 4 game. And so we'll need that state of our Connect 4 game to be shared between all of our players. And so another scenario that can happen is another player could leave in the middle of one of our games. And so if a player gets disconnected and reconnected, we'll need to know what their player ID was and if they're player 1 or player 2. So when we update our game state, we can make sure we put them back into the correct state they were before. Or if they leave the game and a new player joins, we need to have that player assume the role of whichever player that player was. So for our state, we'll need to keep track of which player ID is tied to player 1 and player 2. It will also want to keep track of what moves have already been made in our game. Alright, so for those items we want to be managed by Playroomkit, we'll want to manage these in our global state so then that way share between all players. One of the things we can do when we call insert coin is we can provide the default state that we like to be applied to our global state for each room. To do that, we can add in the property called default states, and now this allows us to provide an object with key value pairs, and then that way when players join, they'll be able to reference this state and grab those values. So this is how we'll start to synchronize our game state between all of our players. So what we'll do now is we're going to define the keys we want on our object. So we're going to come up to the top of our file and we'll make a new object to represent these enum values. So let's do const playroom state keys. For our object, now let's do game state, and we're just going to leave the values empty for now. We'll do moves made for our next key, and then we'll do player 1 ID, and we'll do player 2 ID. So for our values, let's copy our keys, and then we'll do as const. And so now we have our state keys. Let's come back down to our default states, and we're going to add those as keys on our object. So we'll have our playroom state keys, we'll have our game state. For this, we want to do our game state of waiting. So let's do our game state. We'll do waiting for players. Now I'm just going to copy this and do our other values. So now we'll have our player 1 ID. This will be an empty string until our first player joins. We'll have our player 2 ID, and this will be empty until our next player joins. And now we have our moves made, and this will be an empty array until we start our game. Alright, so now we defined our default states. We should be able to grab this when a player joins our room. So if we come back to our callback for when a player joins our room, right after our console log, let's add in one more. We'll do console.log. Let's reference playroom, and we'll call the getState method. So this is going to allow us to grab from our global state. And what we should be able to do is do our playroom state keys. Let's do our game state. If we save, we'll see now back in our browser when our first player joins, we log out that default state that we applied to our global state. Now what we can do is we can reference any of our other properties and we can see what the default value is for those values. Alright, so for now let's remove our console log. And now what we want to do is for our player 1 and player 2 IDs, what we'll end up doing is when two players have joined, we'll randomly choose which player ID is player 1 and which one is player 2. But the main thing we want to do now is when a player leaves our game, we'll want to remove that player ID from our state here. So then that way the next player that joins, we can add their ID in place of the player that left. To make that change, let's come down to our onQuit callback. We'll do if, we'll do our player that left, we're going to grab their ID. If their ID is equal to our playroom.getState, and we'll do our playroom state keys, let's do player 1 first. If their ID matches player 1, we'll want to reset that. So to reset our state, we just call playroom and we call set state. And if we provide the same key, it'll override whatever value we provide. So we'll do our playroom state keys. And now we'll do our player 1 ID and we'll set it to an empty string. All right, then we'll go ahead and return. And if they're not player 1, then we know they're player 2. And so we'll go ahead and reset player 2s. All right, so one thing to note here is we're calling set state, but we're not checking to see if we're actually the host player or not. For our game of Connect 4, this works, and the reason for that is we currently only allow 2 players in our game at a time. And so if a player leaves, that means there's only 1 player left in our room. How Playroomkit manages the host is if the host player leaves the room, another player is automatically elected to be the host of that room. And so if our game supported more than 2 people, then we want to actually add that check to see if we're the host or not. Because we only have at max 2 players, we can safely assume that when there's only 1 player left in the room, they're going to be the host. And so we can override that global state. So this will be something to keep in mind when we call set state later. We'll want to make sure in those checks that we are the host player. Alright, so now we've taken a look at how we can use our Playroom global state to share data between our various players, and we've seen how we can modify that state and retrieve it at runtime. Now we're going to take a look at adding an RPC. So the RPC, or remote procedure call, is a way for us to register a callback or function that we want to invoke on another player's instance of our game. And so this is going to be useful for things like when a player connects to our game or when a player makes a move, we'll want to notify the host player or other players that something has happened. and then that way we can react to it and update our game state. In order to register an RPC, all we need to do is provide a name of an event we want to listen for, and then we provide the callback function, so very similar to our phaser event emitter that we were doing in our local service. So let's go into our register event listeners method, and to add our RPC, we just do Playroom, we reference RPC, and we use the register method. And now we provide the event name that we want to listen for. So for this, we'll make a new object to keep track of these events. So at the top of our file, let's do another object. We'll do const, and we're going to do custom playroom events. We're going to set that equal to an object. And so just to test, we're going to make an event called player connected. We'll keep our value the same as our key. And now we'll do as const. So now let's come back down to our RPC. We're going to reference that event. Now we can provide our callback. All right, so now in our callback, I'm just going to do console.log, and we'll say RPC called. All right, so for our callbacks, for our RPCs, Playroomkit expects these to return a promise. So I'm just going to go ahead and change this to be an async callback, and then we'll go ahead and return a new promise. And so now in our promise, this is where we do our console log. We'll go ahead and save. And so now that we've registered our RPC, now we actually need to emit that event so we can invoke it. To do that, let's come up to our connect method, and after we call insert coin, let's go ahead and emit our event. So now to broadcast this, we need to do Playroom, we need to do RPC, now we need to do call, and now this expects the event that we want to emit. So this will be our custom Playroom events, we'll do player connected. And now we can provide any additional data that we like to be passed to the player. For now, I'm just going to do undefined. And now we need to define the mode of who we like to be notified of this event. So for this, it can be our host, it can be everyone, or it can be the other players for our game. For our test event, we'll do Playroom RPC, let's do our mode, and let's do all. And then since this is a promise, let's just do our catch to handle our errors. And so if we get an error, well, let's go ahead and log that out. We'll do console.log, and we'll log out our error, and we'll go ahead and save. All right, so if we want to test our changes, let's go ahead and click on our launch button for our room. We'll see right away our RPC method is called right after we connect to our service. Now, if we copy our game URL, let's go into another tab, and let's visit that URL. What should happen is now when our player joins, we're going to see that our RPC is called for that player, and on our host player, our RPC is called again since we broadcast that event a second time. So one other thing we can do, just like our event emitter, is we can pass data to the RPC method that will be invoked. To see an example of this, we're going to go ahead and pass in the player ID that just joined. And so we'll define this as a type. So if we come up to the top of our class, let's do export. We're going to do type, and we're going to do player connected event data. And so we'll add in our player ID, and this will be a string. All right, so now if I come back down to our connect method, let's pass in that data to our RPC call. So make a new variable, we'll do player connected data, is our type will be our player connected event data. So we're going to set this equal to our object, and we'll do our player ID. All right, so now for our player ID, we need to grab a reference to this current player's ID. To do this, we can use the Playroom SDK, and now we call the me method, and that's going to reference the player state for this current player of this game instance. So now that we have that, we can now reference our ID property for our player ID. Let's go ahead and pass that into our method here. We'll come down to our RPC event listener, and we'll add that into our callback. Now if we add in data, this will be our player connected event data. And now for our console log, we'll do RPC called. All right, so we'll do our data, and let's do our player ID. So if we save, we come back to our browser, we'll see now as soon as we launch our room, we'll see our RPC is called, and we have our player ID, and this matches our player ID from when we originally joined. All right, so if we copy our URL, let's go to another tab. We'll see for that player, the RPC was called with their player ID, and back in our first player instance, we'll see our RPC was called, and we have that second player ID. All right, so to quickly recap what we just did here is we register an RPC, so our remote procedure call, with Playroom. What this allows us to do is to basically provide an event listener for an event that one player's game instance will emit, and then any other player instance can listen to. When we broadcast that event, we need to choose the target of who's going to receive that event. When we do all, that means all players are going to receive that event. We can change this to be host, and then that's going to allow us to only notify the host player of this event. Or we can do others, which means all other players but this player will receive this event. And so this is very similar to our phaser event emitter, but instead of this being all local to our one player, now we're using this event emitter with all players in our game. And so now that we've seen how we can manage our state and how we can allow the players to communicate by using our RPCs, now we'll start layering in our actual logic for our game of Connect 4. So now to start layering our Connect 4 logic into our Playroom service, the first thing we'll do is we're going to add in logic for when our players join our room. We need to check the total number of players that are currently in our room. So with Playroom, our host player can start our game at any point, and so this could result in when our player joins, we'd only have one player, or we could have both players. For our game of Connect 4, we don't actually want to start this until we have both of our players. Once we have both, now we're going to determine which player goes first, and then we'll update our game state with those player IDs. That way, later on, if a player quits or they get disconnected, we'll be able to update our game state to know which player left, and then as soon as another player rejoins, we'll be able to update our state with that player's new ID. And so this would allow, if the player got disconnected and reconnected, they'll be able to continue playing, or if they left, another player could jump in and pick up from where that player left off. So to start adding this logic, we're going to base this off our player connected event. When we get this event, we're going to do two checks. The first is we'll check to see the number of players that we currently have in our player IDs array. If we don't have two player IDs, then we know we need to wait for our next event, so we won't do anything. If we do have two player IDs, we're going to check to see if we're the host player, and if we're not, we'll ignore the event, since we only want our host player to be the one to update our game state. So our host will be responsible for choosing which player goes first, and then they'll pass that information to the other player. And so for that logic, we're going to add a new method to our class. So instead of returning our promise here, we'll just call our new method. So let's remove this logic here. We're going to do a wait. So for our new method, we're going to call this handle player connected event. Now let's pass in our data for our argument. Let's add this method to our class. I'm just going to copy this. We'll come down here, do async. We'll have our private method. We'll have data. We're going to copy our type from up here. For our return type, we won't return anything, so we're just going to do a promise, and we'll do void. So now in here, let's return our new promise. So we're going to do return, we'll do new promise. So now we want to do our check to see if we at least have two players, and to make sure our players are host. To do that check, we're going to do if, and we'll say this. We're going to reference our player IDs from our local state. We'll do our size. If it doesn't equal 2, we can return, or if we do not, we can do playroom, and we'll do is host. So now is host will tell us if we're the host player or not, and so if we're not, we just want to return. So if we do have two player IDs and we're the host, we're going to log out some information. So we'll do console.log, we're going to do RPC, we're going to reference our custom event that was emitted. So we're going to do our custom Playroom events, let's do player connected. I'll say called with, and let's log out our player ID. And now we're going to grab a reference to our existing player ID. So we'll do const, let's do player IDs, will be equal to array from our set. So we'll have this, and we'll have our player IDs. And let's log that out as well. So we'll do console.log, we'll do our player IDs. So now that we have our two player IDs, now we can actually start our game. To do this, we want to choose which player goes first. And so we're going to want to randomly pick one of our player IDs. And then we'll want to update our game state with who is player 1 and who is player 2. So first, we'll determine which player goes first. So we'll make a new variable, do const first player ID. We're going to set that equal to our phaser. We'll do math random, and we'll do pick to pick one of our elements from our array. Let's do our player IDs. Now we want to get a reference to the other player ID, so whoever second player is. So we're just going to do const, we'll do other player ID. We'll set that equal to our player IDs. We'll do filter, and we want to find the ID that does not equal our first player ID. So we'll say ID does not equal our first player ID. Since this returns an array, we'll grab our first element. Now let's log these out. So we'll do console.log. We'll say first player ID. Now we'll log out our first player ID. I'm going to copy that line, paste it. And now we'll say other player ID, and we'll log that out. Now that we have our two IDs, we'll want to store this in our Playroom state. So we'll do Playroom. We'll do set state. Let's do our state keys. Let's do our player 1 ID first. So we'll pass in our first player ID. Now we want to store our second player ID, so we'll copy this, let's paste it. Let's do our player 2 ID, and we'll update our variable reference. Now that we have both of our players, we can also update our game state that's stored in Playroom. So we're going to copy this, we'll paste it one more time. And now we want to update our game state. Now for our game state, we'll do playing. Now that we've updated our game state, now we can notify the players that our game is now started. So we can do Playroom, we'll do an RPC, let's call, and now we want to do a custom Playroom event. Now we want to add a new event, and we're going to call this new game started. When we emit this event, we want to do this to all players, and so we're going to do Playroom, we'll do RPC, let's do mode, we'll do all, and we'll just add in our catch, and so if we have an error, let's just log it out. Let's add our new event to our custom events. And so we'll have our new game started. And now we need to add a listener for when this event is emitted. So we come back down to where we register our event listeners. I'm going to copy this here. We're going to paste it. Let's do our new event. So we'll have our new game started. For this, we're not passing any data, so we can remove this. And we'll want to follow this pattern where we're calling a method instead of putting all of our logic here. So let's make a new method for this. So we'll do handle new game started event. Remove our argument. Let's copy this. We'll come down to the bottom of our class. Let's add in our new method. And I'm going to come up here. I'm just going to copy this part of our code for our promise. And let's go ahead and log out that our event was called. So I'm going to copy this line of code here before we log out our RPC message. And we're going to change this to new game started. And we'll just say called. So one last change we need to make before we test. Let's come to the top of our code. Let's do import asterisk as phaser from phaser. All right, if we come back over to our browser, we should be able to test. I'm going to clear out our console real quick. So now for our host player, let's do launch. All right, so we should see on our non-host player, we should see that our RPC for new game started was called. And then over on our host player, we should have our details of which player is first, who's second, and then we'll see we call our new game started. Now, since this method was invoked multiple times, we'll see that we're starting our game multiple times. Now we'll want to add in logic to keep track of our game state, and if our game is already started, we'll want to do different logic than start our new game. So if we come back to our code, let's come down to our handle player connected event. All right, so to fix that issue, we need to update our local instance of our game state. To do that, we want to grab that from our Playroom state. So we're going to do this, we'll do our game state. Let's set equal to Playroom, we'll do get state. Let's grab our Playroom state keys, game state, and we'll do as game state. Now that we've updated our local game state instance, down here, before we start doing our logic for our new game, we can add in our safeguard to make sure we're actually waiting for players. So we'll say if our game state is equal to our game state, we'll say waiting for players. Now we want to start our new game, so we'll do this logic here. Let's add in a return. All right, so if our game's already been started, then that means we just received a player connected event, and this could happen for a number of reasons. We might have gotten a duplicate event, we might have had a player left our game and they just came back, or a player left and a new player just joined. So when this happens, we'll need to update our game state to replace whichever player ID just left, or if it's the same player ID, we don't have to do anything. After that, now we need to notify that player that, hey, we already have a game in session, and so here's the state of the game. So then that way we can, in our phaser code, update our board to match our other player's board. So to start making our changes, we'll want to first update our state value for our player IDs. So currently when a player leaves our game, we're resetting it back to an empty string. So now we're going to check to see which of these IDs is an empty string, and we'll want to update that one. So back down here in our code, we'll do if, we'll say our playroom, we'll do get state, we'll do our playroom state keys, let's do our player 1 ID. And so if our player 1 ID is equal to an empty string, we know that player left our game, and so we'll want to update that one. So we'll copy this line of code here, we'll paste it, and now we'll want to use our player ID from our event that we are processing. Now we'll want to do a similar check for player 2. So we're going to do an else if. So now we'll say our player 2 ID, if that's the empty string, now we want to update that value. Now if neither of them are empty string, that means we got a duplicate event and we don't need to update anything in our state. So now that we've updated our state, we'll want to trigger a new RPC call. So I'm going to copy this logic here. And instead of doing new game started, we're going to say existing game. Let's copy this value. We'll come up to our object. Let's add in our new type. Come back down to our code. And so now we'll want to add an event listener for this event type. So let's come up to where we register our event listeners. I'm going to copy this here. We'll paste it. We'll do existing game, and we'll do handle existing game event. Now for this, we'll want to pass through our data of which player that just joined our game, so then that way we can notify that player of the game state. So let's do data, and let's add in a new type. We're going to call this existing game event data. We'll come up to the top of our class. Let's define that real quick. So we're going to do export type. We'll say existing game event data. Then we'll set equal to an object. And for now, we're just going to pass through our player ID. Let's come back down to our code. Let's pass that through. Now let's make that new method in our class. So at the bottom of our file, let's do async. We're going to do handle existing game event. I'm just going to copy this logic here, paste it. Let's add in our argument, and we'll do existing game event data. So now we just want to pass that through when we do our RPC call. So back up here, let's make a new object. We'll do const. We'll say existing game data. We're going to set it equal to. Let's do our types. We'll do existing game event data. Let's do our object. We'll do player ID. And we'll set equal to our data, and we'll do our player ID. Now we just want to copy that variable name, and let's pass that through. And so we'll want to pass that through. All right, we'll save. Oh, and let's make one other quick change. For our RPC call up here, we're just going to pass in undefined for our data that we're passing. And then that way we're setting the correct mode here. So now down in our handle existing game event, let's update our event name, and let's log out our player ID. So we'll do called with player ID. And we'll do our data player ID. So now we should be able to test our changes. Let's come back to our browser. Let's clear out our console real quick. Now for our host player, let's do launch. Now we'll see that first we connect to our service. We see our new game starter was called. And because we have that duplicate event, now we receive our existing game event called. All right, then over on our host player, we'll see first we do our new game. So we'll have our player IDs. And then because we have that duplicate event, now we call existing game. And so just to see one more example of our existing game being called, let's do refresh in one of our browsers. We'll see now that our existing game was called with the new player ID that just rejoined our game. And so now with this logic, we'll be able to handle either of our players disconnecting and reconnecting, or even having a new player join. So now that we're listening for our two events, now we need to emit our event to our phaser game. It'll actually start our Connect 4 game. So we're going to start in our handle new game started event. All right, so when we see this event, first let's update our local game state to show we're playing our game. So we'll do this. Let's do our game state. We're going to set it equal to our game state, and we'll do playing. Now we want to emit out our event to our phaser game, so we're going to reference our event emitter. Let's do emit, and let's do our custom game events, and we want to do a new game started. All right, so next for our handle existing game event method, we only want to process this event for the particular player that it's associated with. And the reason for that is if that player disconnects and they reconnect to our game, we only need to update their local game instance. We don't need to update the existing player's instance. So when we process this event, we're going to grab all of the moves that have already been made for our Connect 4 instance, and then we're going to replay those moves on our local instance. By doing this, now we can pass through our updated board instance to our phaser game, and then that way we can place our tiles where they belong. So to make these changes, we'll first start off by checking our player ID. So we're going to do if our data, our player ID is equal to playroom.me to grab that existing player's profile. If it equals this ID, then we want to process it. So we're going to say not equals, and if it does not equal that, we'll just return early and not do anything. So I'm just going to do a console log. We'll do updating local Connect 4 state. So now from our Playroom state, we'll want to grab the array of all of the moves that have already been made. So we'll do const. Let's do existing player moves. We're going to set equal to playroom. We'll do get state. Now for our state, let's do our state keys, and we'll do moves made. And this will be a number array. So now we want to replay those moves on this local instance. And so we'll do existing player moves. Let's do for each, and we'll say for each move. We'll do this, we'll do our Connect 4, and we'll do make move. So now that we've updated our local instance of Connect 4, we need to pass a copy of that board state to our phaser game. So to do this, we'll need to emit out a new event. So first we'll define our data. So we'll do const. Let's do existing game data. We'll make a new type. We'll do existing game data. We're going to set equal to an object. For our object, we want to pass through our board information. So we'll have board. We'll do this Connect 4, and we'll do our board. Now we need to emit that data with a new event. So we'll do this events. We'll do emit. Let's do our custom game events, and we'll do existing game. And now we'll pass through our data. So now we'll need to define these values. So let's copy this. Let's go into our custom game events. We're going to add in that property. And now we need to define that new type. So let's do our existing game data. Let's do export type. We'll do existing game data. We'll say equal to our board. Now for our type, we want this to be our Connect 4 data, and we'll do our cell range array. So now we defined our new type and we're emitting out our new event. Now we need to update our phaser game to listen for this event. So we'll want to jump over to our game scene. Let's come down to where we listen for our events. We'll add in a new listener. And so I'm just going to copy this here. We'll paste it. Let's do our new event type. We'll have existing game. And then let's add in our arguments. We'll have data. We'll have existing game data. And now we'll just log this out. So we'll do console.log. We'll do data. And I'm going to add a to-do. But for the time being, we're just going to call check for game over. By calling this method, this will re-enable our input if it's currently this player's turn. Let's jump back to our Playroom service. Let's update our imports. Let's save. And now we should be able to test our changes. So if we come over to our browser, we'll see now we have our 2 players. Let's launch our game. We'll see that we have our new game started, and we see our existing game was called. I'm going to clear out our console, and then clear it out over here. All right, so if we refresh our host player, we'll see now we go through our logic for where we made out our event for existing game. We'll see we update our local state, and we get our board information. But then for our other player that didn't refresh, we don't do that update. So if we try refreshing our other player, now it should happen on this player. We update our board state, and over here we're just notified, hey, there's a new player. All right, so one last change we'll make to our code is we're going to update our register event listeners. So when we listen for our on-player join, we're going to move this logic into its own method, and then that way follows pattern here, where we just call another method when we receive this type of event. So let's create a brand new method. We'll have a private method. We're going to call this handle player joined. And we'll have one argument. We'll have our player. Let's do our playroom. And we'll do our player state. For this method, we won't return anything, so we'll do void. And now let's copy our logic from here. So we'll just copy all this logic. We'll place it down here. And now we'll just call our new method from up here. So we'll do this, our handle player joined, and we'll pass in our player. Next, in our Playroom service, now we need to update our getter for is my turn. Currently, this getter returns a hard-coded true value, and now we need to utilize our Playroom's player ID and compare that to our ID that we have stored in our state to see if it's currently this active player's turn or not. By doing this, we'll be able to enable and disable our input in our phaser game, so then that way our player will be able to click and place their game pieces on the game board. To get started, let's remove our hard-coded true value. And now we need to use the current player's instance's ID and compare it to our IDs in our state to figure out if this player is player 1 or player 2. To do that, let's make a new variable. We'll do const. We're going to do is first player. We're going to set that equal to our playroom. Let's call our get state. Now from our state, we'll use our state key. So let's do our playroom state keys. And we're going to do player 1 ID. And so if this ID is equal to our playroom, we'll call me to reference the current player. And we'll grab our ID from our profile. Now we also want to do the same thing for is second player. So we'll do const, let's do is second player. And now I'm just going to copy this line here. Now we just want to update our state key, so we're referencing player 2. All right, so now that we know if our player is first player or second player, we want to compare this to which player's turn it is in our Connect 4 instance. So we're going to do if, we'll do this, we'll do our Connect 4 game instance, our player's turn is equal to, let's do our Connect 4, we'll do data, our player, if it's player 1, and we are the first player, then we know it's our turn. So let's return true. Let's copy this, and we're going to do the same thing where if we are the second player, then we know it's our turn. And if neither of these are true, we're just going to go ahead and return false. Now to test our logic for our is my turn getter, let's jump over to our browser. Let's launch a new instance of our Connect 4 game. We should see right away one of our game instances should show player 1, and that player is able to move our Connect 4 piece around and click on their board. For the other instance, because it's not currently their turn, we show it's player 2's turn, so the other player, and we're not able to actually see our game piece or click on our board. So now that we have this logic, we need to update our Playroom service and add in our logic for actually making a move. So for our make move method, once our player clicks on one of our columns in our game, we're going to want to pass that column ID to our method here. Instead of updating our Connect 4 game state directly, we need to make sure we notify our host player that, hey, this player made a move, and then that way the host player can update their Connect 4 game state, and if it's a valid move, they'll pass that updated game state to both players. This way both their boards will get updated. We want to make sure we do this since our host player is the source of truth for our Connect 4 game. we need to make sure we're updating their state. So in our method, we're going to want to check to see if we're the host player. If we are, then we can just update our game state and pass that data along. If we're not the host player, now we'll want to use one of our RPCs to notify the host that, hey, we just made a move. And then that way we can update our game state. To start making these changes, let's go into our make move method. Let's get rid of our to do. First thing we'll do is make sure it's actually our turn. So we're just going to reference our getter. So we'll say if it's not our turn. So if not is my turn, we'll just return early. If it is currently our turn, we want to see if we're the host. And so we're going to do if, we'll say playroom, we'll do is host. Now we want to go ahead and update our game state and then notify the players of the updated state. For this, we'll make a new private method. So for our method name, we'll do handle move made event. And we'll pass in our column that the player clicked on. We'll just return early. If we are not the host player, now we want to call a new RPC method on the host player's instance. So to do this, let's do Playroom. We're going to do our RPC. We'll do call, and we'll do our custom Playroom events. We'll make a new event. Let's call this move made. And we'll want to pass along our object with which column was clicked on. And now for who we're going to notify, we want to do our Playroom. Let's do our RPC. We're going to do our mode, and we'll reference host. Now let's add in our catch statement. If we have an error, we'll log that. So now we need to define our new event. So let's go to our custom Playroom events. Let's add in move made, and we'll also add in our event data. So let's do export. We'll do type. We'll do move made event data. For our object, we'll just want our column, and this will be a number. So let's come back down to our code. Let's make a new object. Do const. We'll do data. We're going to set our type equal to our new move made event data, and we'll pass in our column. And now we'll just pass that to our RPC call. So now that we have this new RPC, we need to add that to our event listeners. So we'll come down here. Let's copy this logic here for registering our RPC. Let's update this to be move made. Now we'll do move made event data. So when this RPC is called, we're going to want to call this new method that we're going to call here when we're our host player. So for this method, we don't need to be asynchronous. And so we're just going to return a new promise here. So let's do return new promise. So now in our promise, let's call our new method. So we're just going to copy this line of code here. Let's paste it down here. And we'll update our reference. So we'll do data, and we'll do column. So let's get rid of those line of code here. And then we'll add in our new private method at the bottom of our class. So we'll come down to the bottom. So we'll add in our private method, and we'll expect our column. And so this will be a number. For this, we won't return anything. So our handle move made event method, this should only be invoked when our player is our host player. So if our host player makes a move, we're going to call this method directly. And if we're not the host player, we're going to call an RPC method, which our host player will listen for, and then that will invoke our method. So now when this method is invoked, we need to update that host player's Connect4 game instance with the move that was just made. We'll need to keep track of which player made that move and the results of that move. That way we can pass that back to both players, and we can update our game state and show that game piece on our board. To do that, first let's keep track of our current player. So let's make a new variable, do const. We're going to do current player. We're going to set that equal to our Connect4 game instance, and we want to grab which player's turn it currently is. Now we want to make our move and store the results. So we'll do const. We'll do our coordinate from our results. We're going to set that equal to our Connect4 instance. We're going to do make move. And we want to pass in our column from our arguments for our method. Now that we've made a move on our host player's instance, we want to update our Playroom state with that move. So we're going to do Playroom. We're going to call set state. Now we want to do our state keys. Let's do our moves made. And we want to pass in our Connect4 instance and our move history. And so this is important. So then that way when a player rejoins our game, or if a new player joins in the middle, they're going to get a full history of all the moves that were made. That way their game state will be updated appropriately. Now we need to notify our players that a move was just made. For this, we'll do another RPC call, and we're going to pass this to all players. So first, let's define our data we want to pass. So we're going to do const. Let's do data. For our type, we're going to call this game piece added event data. And so on this, we'll want to pass in our coordinate from our move that was made and which player made that move. So let's pass in coordinate. And then we'll pass in player, and so our player will be our current player. Let's define this type at the top of our class. So we'll come up here, let's do export, we'll do type, we'll do our game piece added event data. So first we'll have our coordinate. So now for our type, this is going to be our coordinate from our Connect4 data. Now we'll have our player, and this will be our player from our Connect4 data. While we're here, let's add in our new event type for our RPC, and so we'll do game piece added. Let's come back down to the bottom of our code. So now we'll want to go ahead and call that RPC. So I'm going to come back up here. I'm just going to copy our code for what we call our RPC. For our type, we want to do our new game piece added, pass in our data. Instead of doing our host, we want this to go to all of our players, and then that way we can add our game piece in our actual phaser game state. Now that we're calling this RPC, we need to add an event listener for this event type. Let's come up to our register event listeners. I'm going to copy this line of code here. We'll go ahead and paste it. Now for our type, we want our new game piece added. For our data, we'll do our game piece added event data. And now we want to add a new event to handle this. And so we're going to do handle game piece added event. Let's come down to the bottom of our code. Let's add in our async method. Let's add in our type for our data. And so we'll have game piece added event data. We'll return a promise with void. Now in our handle game piece added event method, this method is going to be called for both of our players. In this method, for our non-host player, we're going to want to update their Connect 4 game state to match which move was just made. This way our game state will stay in sync between this player and the actual state from our host player. Besides that, we also want to emit our event to our phaser game scene that we just added in our game piece, and then that will be our trigger for having our game piece get added to our board, and we'll be able to continue playing our game. To make these changes, let's go ahead and return a new promise. So inside this method here, I'm just going to copy our console log here for we say that we've invoked one of our RPCs. Let's update our reference, and so we'll do our game piece added. And we're just going to do called, and we won't log out any other information. Now we'll add in our check to see if we're not the host. So we'll say if we are not the playroom is host, then we want to update our Connect 4 game state. So we'll do this, we'll do our Connect 4. Let's do make move. And we're going to pass in our data, our coordinate, and which column that our game piece was added to. So for our host player, we're already updating our game state when we call make move here. And now when we call our RPC, this will trigger for both our host and our non-host player. So now that we update our Connect 4 game state to keep it in sync, we now need to notify our phaser game. And so we're going to do this. Let's reference our event emitter. Let's do emit, and now we want to do our custom game events, and we need to do our game piece added, and let's pass in our data. Alright, so if we want to test our changes, let's jump over to our browser. Let's launch an instance of our Connect 4 game. We'll see right away we have our player 1's turn, our inputs enabled, and we can add in our game piece. Our other player is not able to click and add our game piece. So now if we add in one of our game pieces, we'll see both of our game states are updated. We see our game piece is animated onto our board, and now we show which player's turn it is. And so now our other player can take their turn, and we're able to go back and forth. So now for one of our players, we refresh our game. What we should see is that player rejoins our game, and we'll see that it's still player 2's turn, but now we need to add in our logic before we actually update our game board. Now to add in our logic for handling when a player rejoins our game, we're already emitting out an event that has our existing game board state. Our existing game board state is a 1D array that represents all of the game pieces that have already been added. So we'll need to take that 1D array and convert that to our 2D game board state, and then add in our game pieces in the appropriate location. So what we'll see here in our 1D array, we'll see 1s and 2s representing when player 1 or player 2 has added their game piece, and we'll have 0s representing empty spaces. So to add in this logic, let's jump back over to our game scene. In our register event listeners method, we have a to-do for when we get our existing game event. Let's remove our console log and remove our to-do, and now we'll want to loop through that board array. So we'll do data, let's do our board, let's do for each, and so now for each value in our array, we'll want to keep track of our value, our index, and if our value is set to 0, we know it's an empty space, we don't need to do anything. And so we'll just do if our value is equal to 0, then we want to go ahead and just return from this iteration of our loop. If it's not equal to 0, now we need to figure out which position that is on our game board. To do that, we'll use our Connect 4 library. It has a utility method for getting that 2D position. So we're going to do const. Let's do our coordinate. We're going to set that equal to our Connect 4. We want to do our Connect 4 utils. And now we want to do get 2D position. And now we want to pass in that index from our loop. And so now this will give us our 2D coordinate. And now we need to figure out if it's player 1 or player 2. So then that way we can call our create game piece method. For that, we're just going to do const. Let's do player. We're going to set it equal to if our value is equal to 1. All right, so if our value is equal to 1, then we know it's player 1. And so we'll do our Connect 4 data. And we'll do our player. Let's do 1. Otherwise, it'll be player 2. So I'm just going to copy this here. We'll paste it. And we'll do player 2. All Alright, so now with our coordinate and our player, we should be able to call our create game piece method to add in our game piece. So let's do this. We'll do create game piece. For our arguments, we want to do our coordinate. We'll do our row, our coordinate, we'll do our column, and now we have our player string. And is visible, we want to set this to be true since this will be on our board. Alright, so next for our game state, we want to update our game piece texture here when we show which player's turn it is. And so if it's player 1 or player 2, it's going to be red or yellow depending on that player's turn. To add in that change, we just need to figure out which current player's turn it is and then update our texture. So let's make a new variable, do const. We're going to call this next player asset key. We're going to set that equal to our service. We want to grab the current player. And so if that current player is equal to player 1, then we want to do our game assets and we'll do our red piece. If it's player 2's turn, we're going to do our game assets and we'll do our yellow piece. So now we know which texture we want to use. We can call our set texture method on our game piece to update that. So we'll do this, we'll do our game piece, we'll do set texture, and we'll do next player asset key. Besides that, we just want to do our call to check for game over. That will enable our input if it's currently that player's turn, or if the game is actually over, then we'll show the appropriate text to the player. So let's save our changes and now we should be able to test. Let's jump back out to our browser. Let's have both our players join. We'll launch our Connect 4 game. Let's make a few moves, and then that way we can test refreshing our browser. And so now we just made our move over here on the right side. Let's have that player refresh. It should show player 2 when they come back with our 3 game pieces. They shouldn't be able to provide any input. Back on our other player that didn't leave, they can still take their turn. Alright, so if we go ahead and refresh on our left-hand side, we'll see now we'll have our 3 game pieces. Our player can still take their turn, but we'll see we have an issue with our text, and so we'll need to address that. But let's take a couple more moves, and we'll just make sure our logic works. So let's refresh one more time. We should see our 6 game pieces, and our other player can still take their turn. And let's just see if our player can win. So we'll have this player over here win, so we'll add in a few game pieces. Alright, so let's show which player won, and now we just need to add in our logic to fix our text up here. So to fix our issue with our text for which player's turn it is, we need to update our disable input and enable input methods in our game scene. Currently, both these methods have hard-coded text values for which player's turn it is. We're going to want to enhance our service to return this text string, so then that way we can determine which player's turn it actually is. To make that change, let's go into our base abstract service class. And so we're going to add in another abstract getter for getting this text. And so we'll do abstract, let's do get, and we'll do player's turn text. So in this getter, we just want to return a string with which player's turn it is. Let's update our local service to have this new getter. And so after get is my turn, let's do get. We're going to do player's turn text. Our return type will be a string. So now for our return value, now we just want to return our text string that we were returning previously. So either player 2's turn or player 1's turn. So I'm going to copy this here. I'm going to go ahead and just do return for players 2. Now we'll want to check our Connect 4 game instance. And if it's player 1, we'll want to return a variation of this text. So let's do if, we'll say our Connect 4, let's do our player's turn. If it's equal to our Connect 4 data player, if it's player 1, then we want to return player 1's turn. So I'm going to go ahead and save. Let's copy this whole getter. Let's jump over to our Playroom service, and now we need to add that logic here. So come down below our get is my turn. So now in our getter, since this is going to run for both of our players on different instances, we're going to rely on is my turn to return the appropriate text. So instead of returning like player 1's turn, we're going to say your turn or opponent's turn. And then later on, this could be modified to use things like the profile name from Playroom. So to make that change, we're going to do if. We'll say if it's not my turn, then we want to return opponent's turn. Otherwise, we're just going to return your turn. Let's remove this logic here. Now we should jump over to our game scene, and now we can modify our disable input and enable input methods to rely on our service. Now in our disable input method, let's get rid of our text for player's 2 turn. We're going to reference our service, and we'll do our player's turn text. We'll also want to do the same thing down here. We enable our input, so we'll remove this logic, and let's go ahead and save. Alright, so now we save, let's come back over to our browser. Let's get both of our players into the same room. Once we have both of our players, let's launch our game. We'll see now our text is updated with your turn, and that player can actually make their move, and the other one shows opponent's turn. So now if we make our move, we'll see now our text is reflected to show now it's the opponent's turn, and so we can't do anything, but now this player can take their turn. Finally, the last change we need to make for our Connect 4 game is when one of our players wins our game, we want to update our text that's displayed on our screen. Currently, in our base service class, we have our getter for our game winner text, and when one of our players wins, we base that off our game winner from our Connect 4 game instance. And we compare that to which player's turn it was to display that text. For our Playroom service, we're going to also want to rely on our Playroom ID, and if that player is the one that won, we want to modify that text. So to make this change, we're going to overwrite our getter here in our Playroom service. So let's copy this whole logic here. We'll jump over to our Playroom service. All right, so let's go ahead and paste in our getter right above our get player's turn text. All right, so in our getter, the first thing we'll do is we'll keep in our logic for determining if the game winner is undefined. If the game winner is undefined, we'll return the text draw. If game winner is not undefined, now we need to figure out if this player is player 1 or player 2, similar like what we did in Is My Turn. And if that player is the one that won, we'll say you win, otherwise we'll say opponent won. So to add in that logic, we need to figure out if that player is player 1 or player 2. So let's copy these 2 lines of code. Let's paste those down here. All right, so now that we know if this player is player 1 or player 2, we can determine if they actually won our game. So let's do if, we'll say our Connect 4 game instance, if our game winner is equal to our Connect 4 data, player, and we'll say player 1. So if player 1 won and we are the first player, then we can show the you won message. So we'll do return you win. Otherwise, we're going to fall back to opponent 1. And so one other check we want to do is if player 2 won and we're the second player, then we also want to show this text. So I'm going to go ahead and wrap this in another parentheses. Let's copy this line of code here. Let's add in our or statement. So if either of these are true, so if we are player 2 and we are the second player, then we also show that text. So let's get rid of the rest of our code from our getter. Let's go ahead and save. So to test our changes, come back to our browser. Let's launch our game. Let's go ahead and play our game of Connect 4. And so we're going to have one of our players try to win. Oh, and so it looks like we have a bug in our code. So currently, if we click fast enough, sometimes we'll call our make move twice, and so we're adding 2 game pieces. To fix this, we need to come over to our game scene, and in our event listener for our pointer down, after our player clicks, we want to lock our input and wait until we get our results back from our service before we allow them to click again. So to make that quick change, we're going to do this. Let's reference our input, and we'll do enabled. We're going to set it equal to false. So then that way, after we get our make move results and our game piece is added, we'll re-enable our input. Then that way, once we get our results for make move, we'll re-enable our input. So if we go ahead and save our code, let's refresh our browsers. We'll get a new instance. Let's launch our Connect 4 game. And so now we'll try to have our player on the left win. And so we try clicking fast a couple of times. We'll see that now we no longer add our additional game piece. Much better. All right, so now when our player wins, we'll see our text shows you win. And then on our opponent's screen, it shows opponent won. Nice. All right, with that last change, that actually wraps up our game. And there you have it, a real-time multiplayer Connect 4 game built with Phaser 3 and Playroom Kit. I hope this tutorial inspires you to create more multiplayer games using these powerful tools. If you enjoyed this video, please like, share, and subscribe for more tutorials. Got questions or ideas? Let me know in the comments below. For more great Phaser 3 content, please see the links on your screen now.